Today we are going to look at literal equations that are all letters. So not just literal equations where we're solving for y, but literal equations where any number of variables are involved. So the first thing that we want to make sure we remember is that we are still just using our inverse operations. Okay, which means we are still undoing any addition with subtraction, and we are still undoing any multiplication with division, and vice versa, right? We would undo subtraction with addition and division with multiplication. We still want to go in reverse order of operations, right? So if we're seeing addition and subtraction, we are typically undoing that first, just like we would with any equation. So if we look at this first equation, a plus b equals c, this arrow over here pointing to the a is telling us to solve for a. This statement right here is telling us to solve for a. So our objective is then to just look at the a like a variable and pretend like the b is just anything that we want to undo with addition, right? So a and b are attached with addition, and we undo addition with subtraction. So if we wanted to move that b, we would undo adding b by subtracting b. And whatever we do on one side of the equal sign, we also have to do on the other side of the equal sign. Our b's are going to cancel out because if we have the positive and negative of a number, those become 0 and go away. Where our a is left on the left-hand side, and on the right-hand side, we are just left with c minus b. We can't subtract c minus b, so we can't take that any further, and our final answer is just a equals c minus b. If we look at number 2, we have wx equals z, and we are wanting to solve this for x. So our objective is going to be to get x by itself, and sitting right next to x, we have a w. We know at this point that when we see no operation happening in between two numbers, or in this case, two variables, that is multiplication, and we undo multiplication with division. So I'm going to divide by w. And again, whatever I do on one side of the equal sign, I have to do on the other. So my w's cancel out. I am left with an x on the left-hand side, and I just have z divided by w on the right-hand side. I can't do anything with z divided by w, so I just leave my answer there, and that is my final answer. For number 3, we have wx plus b equals c. So we're actually taking the two ideas that we had in number 1 and 2, and we're putting it together in one problem, right? What happens when we have two operations happening and we need to solve? Well, just like we would with any two-step equation, right? We would undo addition and subtraction first. So if this is asking us to solve for x, our objective is going to be to undo the addition and subtraction first. So we undo adding b by subtracting b. Again, whatever we do to one side, we also do to the other side. So our b's cancel out. On the left-hand side, we have wx. And on the right-hand side, we just have c minus b. Our next step to get x by itself is to recognize that when two things are sitting next to each other, that is multiplication. And we undo multiplication with division. So I'm going to divide by w. Now, we talked about this when we solved for y many weeks ago, but we need to understand that there are two things that are equivalent. Dividing this entire side by w, okay, is the same thing as dividing the c by the w and the b by the w. Now, in this particular situation, we can't do anything to simplify in either form. So we would need to have either one of these answers, but recognize that they are the same thing in multiple choice. So if you wrote your answer as c minus b over w, you would get full points if you were doing this as a free response question. But if it was multiple choice, you might see the answer in this format. So you would need to recognize that those two things are equivalent. When we look at number 4, we have c divided by d minus y equals g, and we want to solve this for c. So again, we are undoing our addition and subtraction first. So we are going to undo subtracting y by adding y. Whatever we do on one side, we have to do on the other. Our y's cancel. So on the left-hand side, we have c over d. And on the right-hand side, we have g plus y. But we're not done yet because c is not by itself. So to get c by itself, we need to move the d. The d is attached with division, and we undo division with multiplication. So we're going to multiply by d on both sides. Now, we want to make sure we multiply this entire side by d, which is why I'm putting those parentheses in. So these d's are going to cancel. And again, we can write this as d times g plus y. Doesn't matter if we put that d in front or the d at the end. Or we can multiply that d through just like we would normally distribute, and we can say dg plus dy. So either of these answers would be correct. It was the same idea as the last problem that we would need to recognize in multiple choice if that was one of the options, which one is there. Number 5, we want to solve for g. So if we are solving for g, we need to remember that rule that we learned, again, weeks and weeks and weeks ago, when this large or long fraction bar is happening, that the numerator, the items in the top of the fraction, are grouped together, which means we need to move the denominator first. So we will undo dividing by w by multiplying by w. Our w's will cancel. So on the left-hand side, we will have VW. And on the right-hand side, we will have A minus G. And now we need to get rid of the A. The A is attached with addition or subtraction, but remember our rule says to look in front of it. That A is positive, so we will undo a positive A with a negative A. So we will subtract A from each side. That leaves us over here on the right-hand side with a negative G. That subtraction sign gives us the sign for the G. So now we have VW minus A. But we're not done yet because we don't have G by itself. So we need to divide by that -1 that's really sitting in front of the G. And we're going to use this rule that we talked about up here. While we can just do this whole thing divided by -1, we can simplify with that. So that's the same idea as VW divided by -1 and A divided by -1. And that we can simplify, right? A positive divided by a negative becomes a negative, and a negative divided by a negative becomes a positive. So we would have G equals negative VW plus A. For the last problem that we are looking at, we want to solve for A. So if we need to get to this A, the first thing we're going to have to do is get rid of those parentheses. So we get rid of parentheses by distributing. So 2 times A is 2A, and 2 times W is 2W. Now we have A happening in 2 locations, so just like we would normally do if we have variables in multiple places, we need to combine them. These variables are on opposite sides of the equal sign, so we need to get them together with the opposite sign. So I will move a positive A with a negative A. Right? A 2A minus a 1A will just give me an A. Those A's will cancel. And now I can finish solving for A. So I will undo subtraction with addition. I'll move that 2W to the other side. And I will get A equals H plus 2W.